So next I am going to discuss the term angle of friction. Let us consider a block resting on the horizontal surface. Block resting on a fixed horizontal surface. So let us consider a block of mass m resting on the horizontal floor, the rough horizontal surface of a floor. Then two forces act on the block. One is its weight mg, which acts vertically downwards. Which is the gravitational force of the block by the earth. Second force is the normal reaction force. Exerted on block by the floor. So there are two forces acting on the block here. One is its weight mg, second one is the normal reaction force on block by the floor. So when the block is in static equilibrium on the floor, these two forces act along the same line through center of gravity in opposite directions. But for clarity of the discussion, we try to show the two forces. The lines of action of the two forces slightly separated. That means if no horizontal force applied on the block, in the figure on the left side, no horizontal force is applied on the block, then no frictional force acts on the block. Now I consider the situation when a horizontal force is applied on the block. Suppose if a horizontal force is applied on the block towards right, then the force of friction on the block by the floor acts towards left side. Let us suppose the horizontal force applied on the block is very small, not sufficient to start the block moving. That means the horizontal force applied on the block less than the limiting friction. That is when the block is at rest, the frictional force of the block will be called as static friction. And magnitude of the static frictional force of the block by the floor is same as the magnitude of the horizontal force applied on the block. Of course, let us consider other forces which act on the block are the weight mg of the block and normal reaction force. The weight mg of the block and normal reaction force act along same line in opposite directions. But here for discussion, I have shown normal reaction to be slightly separated. The line of action of normal reaction slightly I have shown separately from mg. So in this free-body diagram, n represents the magnitude of normal reaction force on the block by the surface of floor. Fs is the magnitude of the static frictional force exerted on the block by the surface of floor. So one may get a doubt how floor exerts two forces on the block. You can say this way, N is the, normal reaction, is the vertical component of the force exerted on the block by the floor. Fs, that is magnitude of static friction, is the horizontal component of the force exerted on the block by the floor. So N is the magnitude of the normal reaction force exerted on the block by surface of floor, which represents the vertical component of the force on block by floor. Fs is the horizontal component of the force exerted on the block by the floor. So the actual force exerted on the block by the floor, I mean net force on the block by the floor, will be the resultant of normal reaction and frictional forces. So you can complete the rectangle by representing the normal reaction force and static frictional force by the adjacent sides. The diagonal of the rectangle represents the resultant of normal reaction and frictional forces on block by the floor. So the resultant of normal reaction and friction forces exerted on the block by the floor is called as total reaction force on block by the floor. I denote the magnitude of this total reaction by capital R subscript T. So you need not write the notes at present. I will show you the notes separately after the discussion is completed. So those who are writing the notes or those who want to write the notes, they can stop writing now. They can just concentrate on listening. Later I will show you the notes, which you can copy if you are interested to write the notes. So here the resultant of normal reaction and friction forces exerted on the block by the floor is called total reaction force on block by the floor. Because normal reaction and frictional force are perpendicular to each other, the magnitude of the total reaction force on block by the floor is given by under root of n square plus fs square. This RT represents, capital R subscript small t represents the magnitude of the total reaction force on block by the floor, which you can also say that RT represents the magnitude of the contact force between the block and the floor. That means RT represents the magnitude of the net force on block by surface of the floor in contact. So in general, when a block is placed in contact with a surface, the resultant of normal reaction and frictional forces on the block by the surface in contact is called as the total reaction force on the block by the surface in contact. This total reaction force makes some angle alpha with the vertical direction with a normal reaction. So here I have constructed a rectangle by representing normal reaction static frictional forces by the adjacent sides of the rectangle. So the diagonal of the rectangle represents the total reaction force. Now in rectangle opposite sides are equal. So length of this side will also be equal to Fs. So we have a right angle triangle here. In this right angle triangle, length of side adjacent to the angle alpha gives you the magnitude of normal reaction on block by floor. Length of side opposite to the angle alpha gives you the magnitude of static friction force on block by the floor. So you can write tan alpha equal to length of the side opposite to the angle alpha divided by length of the side adjacent to the angle alpha. So tan alpha equal to Fs by n. So with increase in the as explained in the earlier class, when the magnitude of the horizontal force applied on the block is increased gradually, the magnitude of static friction force on the block also increases. When magnitude of static friction force on the block increases, alpha increases. That means the angle alpha between total reaction and normal reaction will increase with increase in the horizontal force applied on the block. The angle alpha reaches the maximum value when the static friction between the block and the floor reaches the maximum value. The static friction between the block and the floor reaches the maximum value at the instant just before the block starts sliding along the floor. When the static friction between the block and the floor reaches the limiting value or maximum value, then the block is said to be limiting equilibrium. So tan of the maximum value of alpha, can write maximum value of the static friction by n. Maximum value of static friction between the block and the floor is called as limiting friction, which is magnitude of the limiting friction is given by nu as to n, where nu as is the coefficient of static friction between the block and the floor. So the maximum value of this angle between total reaction and normal reaction at the instant when the block is in limiting equilibrium is called as the angle of friction between the two surfaces. This angle of friction is denoted by phi, that means alpha maximum denoted by phi. Maximum value of alpha is denoted by phi. So the maximum value of the angle between total reaction and normal reaction at the instant when the block is in limiting equilibrium, that is at the instant when the static friction of the block reaches the maximum value, is called as angle of friction between the two surfaces. So tan phi can be written as equal to nu s. So if phi is the angle of friction between two surfaces in contact, then we can write tan phi equal to nu s, or nu s equal to tan phi. Or if nu s is the coefficient of static friction between two surfaces in contact, then the angle of friction between the two surfaces in contact can be written as tan inverse nu s. As I discussed earlier, the value of the coefficient of static friction nu s is a constant for a given pair of surfaces in contact. Therefore, the angle of friction phi will also be considered as a constant for a given pair of surfaces in contact. And sometimes you may be asked to find maximum value of the total reaction. The maximum value of the total reaction. The magnitude of total reaction reaches the maximum value at the instant the static friction reaches the maximum value. That is root of n square plus fs maximum square. Maximum value of the static friction is equal to nu s into n. So I can write maximum value of total reaction is equal to under root of n into under root of 1 plus nu s square. I mean, when the horizontal force applied on the block is suppose increased gradually from 0, as explained earlier, the magnitude of static friction of the block also increases from 0 to the maximum value. So magnitude of the total reaction is minimum when static friction is minimum. The static friction will be 0, then no horizontal force applied on the block. In the first figure on the left side, no horizontal force applied on the block. In this case, static friction of the block will be 0. Then magnitude of the total reaction will be same as normal reaction. So minimum value of the total reaction is equal to normal reaction. So I would like to summarize the same discussion again. So I am going to show you the notes for this discussion. I am going to show you the notes for this summary of the discussion I have done about angle of friction. So those who want to write the notes or copy the notes, they can get ready with a pen and paper or notebook and pen. So come on, look at the summary of the discussion about angle of friction. First point, when a block is placed in contact with a plane surface, the resultant of normal reaction and friction forces on the block by the surface in contact is called as the total reaction force on block by surface. So magnitude of the total reaction, can it RT equal to under root of n square plus small f square. So I would like to summarize the discussion about angle of friction. Look at the diagram that is given there on the screen. So those who want to write the notes, they can start writing the notes. They can first copy this figure. In the figure, you can observe that here kept left is the magnitude of the horizontal force applied on the block towards right. Left side Fs represent the magnitude of the static friction force on the block by the floor. Here N represents the magnitude of the normal reaction on block by floor. This weight mg and normal reaction are shown separately along different lines only for clarity. But actually both N and mg act along same line in opposite directions. So here normal reaction is the vertical component of the force on block by floor. Fs is the horizontal component of the force on block by floor. RT represents magnitude of the total reaction on block by floor. Or you can say RT represents the magnitude of the contact force between the block and the floor. The magnitude of the total reaction is the resultant of normal reaction and static friction. Come on, those who are writing the notes or copy down the diagram. In case you need more time to copy the diagram, you can take a pause and take more time. Next, I am going to show you the notes for the angle of friction. The block is placed in contact with a plane surface. The resultant of normal reaction and friction forces on the block by the surface in contact is called as the total reaction force on the block by surface. Come on, those who want to copy this, they can start writing. So magnitude of the total reaction is given by RT equal to under root of n square plus small f square. Here small f represents the magnitude of friction on block by floor or by surface in contact. And the block is at rest tan alpha equal to Fs by n. Here alpha is the angle made by the total reaction force with the normal reaction force. So those who want to write the notes or those who are writing the notes, come on, copy down. Here alpha represents the angle between total reaction and normal reaction. So tan alpha equal to Fs by n. As I explained earlier, alpha is maximum when the static friction reaches the maximum value. So tan alpha maximum, you can write Fs maximum by divided by n. Fs maximum, you can write us into n. This alpha maximum, I mean maximum value of alpha is denoted by phi. That is called as angle of friction between the two surfaces. Those who are writing the notes, come on, finish writing. In case you need more time to copy the notes, you can take a pause and take more time. So I have given the definition for angle of friction. The maximum value of the angle between total reaction and normal reaction. When the block is in limiting equilibrium, is called as the angle of friction between the two surfaces in contact. If phi is the angle of friction between the two surfaces in contact, then we can write us equal to tan phi or phi equal to tan inverse us. When us is the coefficient of static friction between the two surfaces in contact. Come on, Type down this point. Finish writing. Those who are writing the notes, come on, finish writing. In case you need more time to copy, you can take a pause and take your time. So as nu is a constant for a given pair of surfaces, you can say the angle of friction phi is also a constant for a given pair of surface in contact. Next, I am going to discuss some special cases, mostly in friction. Most of these special cases are related to the motion on the horizontal plane. First, I discuss each special case on the screen. You just listen to the discussion I do. That means you just concentrate on the explanation I discuss. So later I show you the notes part separately for each special case. Those who are writing the notes or those who are copying the notes, they can write the notes when I show the typed format or the PowerPoint presentation. So when I am explaining, you need not try to write running notes. You concentrate on listening to the explanation part. So there are a good number of questions based on these special cases, which are given in the different books and also in previous entrance examinations. So I would like to discuss some special cases of motion on the horizontal plane. So I am going to discuss the special case 1. Let us consider a block. So let us consider a block of mass m resting on a horizontal floor. Let us consider a block of mass m resting on a horizontal floor. Let us suppose us is a coefficient of static friction between the block and the floor, and uk is the coefficient of kinetic friction between the block and the floor. So the weight mg of the block acts vertically downwards, which is the gravitational force of the block by the earth. Secondly, the normal reaction force on the block by the floor acts vertically upwards. Here n represents the magnitude of normal reaction force of the block by surface of floor in contact, which acts perpendicular to surface of floor in contact, directed away from surface of floor in contact. Suppose if a horizontal force applied to the block towards right, then friction force on the block by the floor acts towards left side. I choose the horizontal direction towards right, that is the direction of the horizontal force applied as positive x-axis, and vertically upward direction as positive axis. So you can write y component of the resultant force of block is n minus mg. The block has no motion in the vertical direction, and the block has no acceleration in the vertical direction. Then we can write y component of the resultant force of block is 0. So magnitude of the normal reaction on the block is the same as the magnitude of its weight mg. So magnitude of the limiting friction between the block and the floor means maximum value of the static friction is equal to nu s into n or nu s into mg. If a horizontal force applied to the block when it is initially at rest, the block starts moving only when the horizontal force applied to the block just exceeds this limiting friction. I mean when the horizontal force is suppose increased gradually. Starts moving only when the horizontal force applied to the block just exceeds the limiting friction. Let us suppose a horizontal force which is just sufficient to start the block moving is applied on the block. I mean the the horizontal force applied to the block is equal to the least horizontal force needed to start it moving. And let us suppose same force is maintained even after the block starts moving on the floor. Once the block starts moving on the floor, friction for the block during motion on the block along the floor will be denoted by Fk, which we call kinetic friction. Let us suppose the horizontal force which is just sufficient to start the block moving is applied to the block, and same force is maintained even after the motion begins. So resultant force on the block when it is moving along the floor we call X component resultant force, because Fy is 0. Capital F is the magnitude of the horizontal force applied to the block which acts along positive direction of x-axis. Fk represents the magnitude of the kinetic friction force on the block by the floor which acts towards left in the negative direction of x-axis. So resultant force of the block in the horizontal direction we can write capital F minus Fk. From Newton's second law, resultant force of the block can be written as product of its mass and acceleration. So in this case, the horizontal force applied to the block is equal to the least horizontal force needed to just start it moving. That means you can take magnitude of the horizontal force to be equal to the magnitude of limiting friction. And magnitude of kinetic friction of the block during the motion is equal to nu k into n, or nu k into mg. So we'll substitute here on the left side capital F equal to nu s mg and Fk equal to nu k into mg. Therefore we get nu s into mg minus nu k into mg. That is equal to mA. So or you can write nu s minus nu k into mg equal to mA. Nu s minus nu k into mg is equal to mA. So if we divide the equation with mass m, we get acceleration A equal to nu s minus nu k into g. So the conclusion is that if horizontal force applied to the block when it is initially at rest on the rough horizontal floor, which is just sufficient to start the block moving, and if the same force is maintained even after the motion begins, then magnitude of acceleration of the block is given by A equal to nu s minus nu k into g. I would like to show you the conclusion on the screen. Come on, those who are writing the notes, they can again start writing. And they can put the heading special cases in motion horizontal plane. Case 1. I'll read out the conclusion. First I have given the conclusion, later I show you the working, which I have just discussed before. Consider a block which is initially at rest on a rough horizontal floor. If a horizontal force is applied on the block, which is just sufficient to start the block moving, and if the same force is maintained even after the motion begins, then the acceleration of the block is given by A equal to nu s minus nu k into g, where nu s and nu k are the coefficients of static and kinetic friction between the block and the floor respectively. So those who want to copy the notes, come on, start writing the notes. In case you need more time to copy the notes, you can take a pause and take your time. I'm going to show the working for this conclusion, which I have just discussed before this. The figure shows the free body diagram for the block. F bar is the horizontal force applied to the block which acts towards right. Weight mg acts vertically downwards. N is the magnitude of normal reaction force of the block which acts vertically upwards. Fk is the magnitude of kinetic friction of the block which acts towards left side. So figure shows, you are given the free body diagram. Figure shows the force acting on the block during the motion. That is free body diagram for the block during the motion. Choose the horizontal direction, which is the direction of the motion of the block at x-axis. Vertical upward direction of the axis. So those who are writing the note, they first copy the free body diagram. Then they can copy the working part. Fy means by component resultant force equal N minus mg. That can be written as 0 here. Or you get N equal to mg. So resultant force of block during the motion. We write Fx means x component resultant force. That you can write capital F minus Fk. From Newton's second law, that can be written as equal to m into a. Here F equal to us into n, that is us into mg. And Fk equal uk into n, that is equal to uk into mg. So if you substitute here F equal to us mg and Fk equal uk into mg on the left side, you get the last equation, us mg minus uk into mg equal mga. Come on, those who are writing the notes, come on, keep writing. If you divide the equation with m, you get us minus uk into mg equal mga, or you get a equal to us minus uk into g. Come on, those who want to copy the notes, finish writing. In case you need more time to copy the notes, you can take a pause and take your own time. Next, I am going to discuss the second special case. That is based on stopping distance. So here I am going to discuss next second special case. Let us suppose a block is thrown along a rough horizontal floor with some initial speed u and left. That means no accelerating force is applied on the block in the direction of the motion while it is moving. The block is just thrown. That means just kicked or pushed by applying an impulsive force and left. So it just starts moving. Then I am going to calculate the distance with the block travels along the floor before it comes to rest in terms of the initial speed u and coefficient of friction between the block and the floor. So I am going to show you the free body diagram for the block during the motion. The first axial force which acts on the block is its own weight mg, which is a gravitational force on the block, but that it acts vertically downwards. Then the normal reaction force on the block by the floor acts vertically upwards. Here n represents the magnitude of normal reaction force of block by the floor which acts vertically upwards, perpendicular to surface of floor, direct away from surface of floor. Then force of kinetic friction on the block by the floor acts opposite direction of the motion. Here Fk represents the magnitude of sliding friction or kinetic friction block by the floor which acts towards left side. You need not write the notes now. You can write the notes later. When I will show you the notes separately, typed form of the notes. So those who want to write the notes, they can write the note later. Just now concentrate on listening. The vertical upward direction, I take it as positive y-axis, and the horizontal direction, which is the direction of the motion of the block, as x-axis. So y component resultant force on the block, that is resultant force in the vertical direction, is equal to n minus mg. But here the block has no acceleration parallel to y-axis, so y component resultant force 0. So magnitude normal reaction of the block is equal to 8 mg. So resultant force of the block when Fy is 0, resultant for the block is equal to Fx. Resultant for the block during the motion. The only force which acts on the block in the horizontal direction is the force of kinetic friction or sliding friction by floor on block, which acts opposite to the direction of the motion in the negative direction of x-axis. So we can write Fx equal to minus Fk. The negative sign is used because x component of the resultant force is directed toward left side, opposite to the motion. From Newton's second law, resultant for the block can be written as product of its mass and acceleration. But magnitude of kinetic friction, Fk represents the magnitude of kinetic friction on the block by flow, that can write nu k into n or nu k into mg. So we'll substitute Fk equal nu k into mg on the left hand side of the equation. Therefore, acceleration of the block during the retarded motion along the rough floor under the action of weight mg and normal reaction and Fk will be given by A equal to minus nu k into g, or you can say retardation of the block when the block slides along the rough floor when no accelerating force is applied in the direction of its motion while it is moving, given by nu k into g. So if the coefficient of friction between the block and the floor is constant, that means if the floor is uniform, equally rough at all positions during the motion of the block, the coefficient of kinetic friction between the block and the floor is constant throughout the motion, then its acceleration of the block can also be assumed to be constant. Then we can use the equations of one-dimensional motion with constant acceleration. So to find the distance traveled by the block before it comes to rest, we can use the equation v square minus u square equal to as. The final value on the block stops, you can take v equal to 0. A equal to minus nu k into g. So distance traveled with the block along the rough horizontal floor before it comes to rest is given by s equal to u square by 2 nu k into g. This distance traveled by the block along the floor before it comes to rest we call stopping distance, which is given by u square by 2 nu k into g. Sometimes you may be asked to find the time taken or time after which the block comes to rest. Then you can use the equation v equal to u plus at. Suppose if capital T is the time after which the block comes to rest, can write here A equal to minus nu k into g into capital T. Small t can be written as capital T. That means capital T is the time after which velocity becomes 0. That means at small t equal to capital T, v is 0. Then you can find the time taken by the block to come to rest. So in the previous entrance examinations, both in EAMCET and All India medical entrance exams, you are given some problems and questions based on this discussion. So time after which the block comes to rest is given by t equal to u by nu k into g. Next, I am going to show you the same this case 2, the typed form, printed form of this. You can see it. Those who want to write the notes, they can start writing the notes next. So come on, see the case, those who are writing the notes. So I advise everybody to write the notes if they are able to find time. So you see the case 2, first I have given you the conclusion on the screen. If a block is thrown along a rough horizontal floor with initial speed u and left, and the distance traveled with the block before it comes to rest during the retarded motion under the action of the forces mg, comma n and fk is given by S equal to u square by 2 nu k into g. First you copy this conclusion. Next I will be showing you the working. In case you need more time to copy the conclusion, you can take a pause and take your own time. So I am going to show you the working here for this. Copy the free body diagram. The free body the diagram, first I have shown the initial position of the block. This figure, the dotted line, broken line shown, this is the position of the block at some instant during the motion. NG acts vertically downwards, normal reaction force on the block acts vertically upwards. FK represents magnet of kinetic friction on the block by the floor which acts toward the left side opposite to the motion. The free body diagram, instead of capital F subscript K, you write small f subscript K when you copy in the notes. You can copy this working on the left side after copying the diagram. You can write Fi equal n minus mg equal 0 or n equal mg. Resultant for the block equal to Fx, that can be written as minus Fk. That can be written as equal to Ma from Newton's second law. But Fk equal uk into n, can write n equal mg. So you can substitute Fk equal uk into mg on the left side. You get minus uk into mg equal to Ma or A equal to minus uk into g. Come on, copy down. In case you need more time to copy this working, you can take a pause and take your own time to copy the working. I would like to show you the working continuation to this. Or you can write retardation equal uk into g. You can say that acceleration A is constant if uk is constant. So using the equation v square minus square equal to as, you get 0 square minus u square equal to 2 into minus nu k into g into s. Or s equal to u square by 2 nu k into g. Come on, copy down the working. For the stopping, this distance traveled with the block before it comes to rest during retarded motion, we call usually as stopping distance. You can observe that stopping distance is independent of the mass of the block. For example, if two blocks of different masses with similar surfaces are projected along same rough horizontal floor with equal initial speeds in parallel directions so that they don't collide with each other, then both the blocks travel same distance before coming to rest if the coefficient of friction between each block and the floor is same. So in case you require more time to copy this notes, you can take a pause and take your own time. So there are some more special cases which I have to discuss. I will be discussing. I will continue the discussion of this special case in next class. The next class I will be discussing case 3, where the case where pulling force is applied on the block at some angle theta to the horizontal, then pushing, pulling, etc. These cases I will be discussing in my next class.